All right, let me get settled in here. Got my tea. I think we're ready. Hey, what's up guys, and welcome to my first YouTube video ever. My name is Ghost. I'm a C and C++ programmer and software engineer. And today I have something exciting because I am working on electronics. Now, electronics isn't my field, but I'm starting to get into it as a hobby. And I created this cool little simple design that I'll show you right now. So what I built is basically a grocery list. And here you have 3 buttons. You can click up to go up through the list, down, and then the 3rd button allows you to remove an item from the list. The list has the wrapper. Basically, it wraps to the front once you reach the end of the list, and vice versa. And I mean, that's pretty much it. Like I said, it's a very simple design, but I just wanted to create something very simple for beginners and myself as far as getting into a little bit of electronics / circuitry. I just want to create something very simple. And in this video, I'll go over more about the programming and less about the actual circuitry, but I will briefly go over how to wire it really quickly, but go more in depth about the actual programming. I will also have a GitHub repository linked in the description below, so that way you can download. It'll have the program and it'll also have the wiring diagram, so that way you could, don't mind, that's my guinea pigs over there. So yes, it will have the wiring diagram and it will have the code, so that way you can just use it. But like I said, I will be going in depth, line by line, explaining each line of code as I go. Let me stop rambling. Let's just get into it. Okay, so first things first is we need a breadboard, right? Now this breadboard comes with a kit. So this is the kit that I bought on Amazon. I'll leave a link in the description below. Next, we have our microcontroller. This is the Uno R3. I'm not sure if you ever used this before, but this is how it looks. Now, mind you, once again, I don't know that much about electronics. I only talk about what I do understand. Most of you probably know more than me. I am gonna wire this with you and kind of discuss what I do know. Next, we have the LCD, which is the 1602. Next, we have our potentiometer here, which is gonna control the contrast of the LCD screen. 3 tactiles. 1 button is going to be for the up, the other button is going to be for the down for navigation, and then the final button is going to be for removing items. And then we just have a bunch of general wires here. Okay, so first things first is we're just going to put in our LCD. So we'll put it over here, put it like right around here. We're going to put our potentiometer. So it has 3 pins. 2 here, 1 here, and here, the single one is gonna go closer to where the LCD on this side, and then the 2 over here is gonna go on that side. We'll put it kind of close to the screen here because it has to go into this pin here, the VO. Next, we have our buttons. We're gonna put our buttons towards the end of the board over here. Okay, cool. So let's begin wiring. So we have, as you can see here, the 5 volts right here. So we're going to connect a red wire to 5 volts here. And we're going to connect it on the red line here, which is for positive. Next, let's see. I guess we'll focus on the A and K first, which is these pins right here. So basically what the A and K is the A, I believe, is the anode, which basically like supplies power to the backlight, and then the K, long story short, the A and K supplies the power to the actual backlight. Since A is the anode, we're going to use a red wire, so we'll connect it here to our positive over here, and then the capital one connect here to the ground. So we're gonna connect the ground from our microcontroller to the negative side. So next, we're gonna worry about our data pins, and we're gonna worry about the data pins specifically between D4 to D7. We're gonna set them 9 through 12. So that's coming along. Next, we need to attach E, and we're gonna put that on pin 8. Next, you have the RS and the RW. So what the RS is the register select, the RW is the read and write. Basically what the register select does is that it has a low and high mode. So basically the low, from my understanding, does commands like such as like clearing the screen and also like setting the cursor. And then the high mode handles the it's basically like the data mode where you can send characters to the actual columns on the LCD screen. So we'll connect the RW to the ground, and then the RS we will connect to pin 7. Next, what we need to do, we need to supply power. This is going to be the VSS and the VDD. So then we connect VDD to positive. And now we're going to connect the potentiometer, which is this here. That single pin, we're going to connect it to the VO. The ground goes on this outer part over here. So we're just going to connect ground to it. The other one over here to positive. Now all we really need to do is just connect up our buttons. The outer pins are the ground, and then these other pins are basically what are going to connect to these pins here. This button is going to go to pin number 2. This button here is going to go to pin number 4. This one's going to go to pin number 5. And there you go. Completely wired up, ready to go. Next, we will begin the code. So first things first is that we need to think about our requirements. And in this case, we need a library. And this library is called Liquid Crystal. It is used for the LCD. If you don't have it downloaded, you go to Tools here. You go to Manage Libraries. Right there, Liquid Crystal. Make sure it is by the actual company Arduino. Mine's already installed, so I don't have to install it, but it would say obviously install here. Besides that, you should be good to go. So at the top here, you're going to want to include it. And then next, we need to set up an instance of Liquid Crystal. Okay, so we set up this instance here, we'll call it LCD. And then we're going to pass in the pins. So these are the pins that we are using on our board that's going into our LCD. From here, we're going to be moving on to the field and what we need as far as global variables. Okay, first things first is we have buttons, right? We have 3 buttons. So let's just define those pins. So we have our up button, which is the button all the way to the left of the board. Up button pin equals 2, and we have the next button right next to the up button, which is our down arrow, that equals 4. Finally, the last button, which is going to be the button that is able to remove items from the list, which is at pin 5, which we will name I guess submit. All right, now another thing we need is we need some sort of flag to indicate whether a button was pressed, and this flag is going to be used for all buttons across the board. So it's going to be a boolean is button pressed, and I'm going to set it to false. Okay, moving on. So now we're going to create a checklist. There's no way to currently add new data to our list. That's a challenge left for you. If you want to attempt to, I'll leave it in the repository. For now, we're just going to populate some predefined finite list. So here we go. This is our list. So we have 15 items. Next, we need to track which one that we're currently on. So we're just going to call this index equals 0 for the first item. And then finally, we also want to track the list size, because as you begin to remove items, we need to virtually track the list size, because we're not going to keep creating new arrays and moving items over each time, because that's just way too expensive. So we're just going to virtually track the size. I'm not sure if you know how to get list size from arrays, but basically you just take the size of the actual list itself, and then the size first element, which just basically gets the type. All right, moving on. Now this is just some miscellaneous stuff. The first thing that we need, 0. So basically what this is going to do is going to track time. So each time you click the button, it's going to track the previous time recorded in milliseconds. And this is just to set up some spam control, so that way you can't spam the button. We need another variable, which will basically be the cooldown amount. We'll put it at 500 for now. Next, so we need to track the arrow position. Now, the arrow is basically going to be highlighting the item that you're currently on, priming it for removal. So we're just going to track where you are, where the arrow is in position, and there's only like 2 positions. There's either 0 or 1 because LCD only supports 2 lines starting at 0. All right, so first things first is we're going to set up our pins for our buttons. If you already know how to do this, there is a function for that called pin mode. If you don't, it's called pin mode. And basically what you do is you just take our variables up here. In this case, we'll start with the up button pin. You pass it in as the first argument. And then for the second argument, since this is going to be input, there is a predefined macro, which basically is called input pull up. What that does is that just indicates that we are listening to input, and that's what we're taking in. So it's not output, it's input. I don't know why I'm over explaining that, but that's what it is. And we're gonna set up the other buttons like so. So I'm just gonna copy and paste this to save a little time. So our LCD supports, I believe, like, I don't know if it's 15 or 16 characters. And like I said before, it's only 2 lines. So we need to actually specify that. So we'll say using our instance for our liquid crystal, LCD.begin, passing the argument starting with the number of columns, which is going to be 16, and any number of rows, which is going to be 2. Next, I want to display a message when you first plug in the device on the first line, which is going to display grocery lists, and in the next line it will give like your first item. And then after that, once you start using the buttons, then it'll just be nothing but the items, and that initial message will go away. So I just figure it's best to put it right here in the setup. And once again, you're going to use the instance LCD, and you're going to use the print function. It just prints any string that you pass to it. Now, this one we didn't implement yet. It is a custom function that we will create a little later on, but it's going to be called a render item, self-explanatory, which basically just renders a specific item. And we're going to pass in the index, which is going to be that tracker that specifies where we currently are, A1 and true. Now I will clarify exactly what the rest of the arguments are later on when we get there, but that's what we're going to pass in. And for now, we'll just comment this out because it's not yet made. But that's it. That is the end of our setup. Next, we are going to start defining those custom functions, and then finally we'll go into the loop, and then we should be ready to go. Okay, so moving on to our custom functions. So I already created the signatures real quick. We only have 2 custom functions. One of them is called the render item, which I was already explaining, and the other one called the remove item. So we will start with the render item. Okay, so the arguments. So like I stated before in the setup, so we're going to pass in, the first argument is going to be the current index, and then the next one is going to be the line in which we want to render the item on. Remember, there's 2 lines. There's 0 and 1. And then finally, there's going to be a boolean for a has arrow. Basically, because the arrow will be able to move on the bottom line whenever you're moving down, and then it will go to the top line whenever you're moving up, and it will stay on either or depending on the last button that you have pressed. So we need to be able to know where the arrow is. All right, so first things first is we are going to check the list size and to determine if there's nothing more to display. And if there's nothing more to display, then we want to return early and not render the item that we're attempting to render. We are going to say if list size, which is the global variable that we're using up here, equals 0, right? Then what we want to do here is that we just want to display a message to the LCD that the list is empty. Now, this will only happen once, and you will see why later on, because basically in the loop we're going to also look for this, and we're going to return out, so that way we don't run no more logic anymore. But we'll get into that later on when we actually go into the loop. So next, we're going to set the cursor. At this point, we're going to set where we're going to print the actual item. Remember, 2 lines, 0, 1. So you can use the instance lcd.set cursor function. 0 because we're for the first argument, because we're not gonna skip any columns. We're gonna start at the first column. But for the second one, which is the actual row, we're just gonna pass in the parameter line next. So at this point, we need to build the string in which we're gonna actually print. And there's a couple things that we actually need to attach to it. The first thing we want to attach to it is we want to take the current index that we are on, but since indexes in the case of arrays start at 0, we need to push it to 1. So we'll do that, and then we'll convert it into a string, and then we'll start to build a string and concat everything else to it. So we need an array that's going to be able to hold this, and now they're only up to what I said before, like 16 characters, as you can see here, per line. So that's all we really need, but I'm just going to create an array at 20, I guess. So char string set the size to 20. So that's going to be where the full string is going to exist. And then here, we're basically going to start with the index and then keep going. So we need to convert the index, since it is an integer, into a string. All right, so basically what this does is it just takes in 3 arguments, takes in our string, right, which is where we're actually going to push everything to. Takes in this expression, which basically just determines that this is going to be a decimal numerical. And then finally, the actual value that we're trying to put into the string. And I already explained the index plus 1. Another thing I want to do is I want to make it a little bit nicer and put like a period after the number and then a space before the actual item. So we're just going to put that in with string concat, which is another function from C. We pass in again the string, and then for the second argument, we're going to pass in just the string literal. Nope, not colon, a period and a space. So that takes care of that. And then lastly, we want to pass in the actual item. So string concat again, string. And then for the second argument, since we are just going into the actual list using the index to get that current item, the string should look presentable. So we're going to now focus on the arrow. We're going to determine if there is an arrow or not, because we don't want to just attach an arrow to both lines. So using the actual Boolean, we ask if has arrow, and then all we're going to do is just another concat, basically. So string concat string, and we're going to use this type of arrow, just like that. Make it simple. And lastly, all you need to do is just take the instance lcd print string. Yep, that looks good. So that's pretty much it for the render item. Okay, so for the remove item, like I stated earlier, we are not going to be creating new arrays, copying things over. That's just way too expensive. So all we're going to do is just do this neat little trick where we're going to shift all the items over one by one, depending on where you actually are removing an item from. So you can remove it anywhere in the middle of the list or at the end, doesn't matter. It'll just shift every item and then put the empty strings towards the end. But first things first, let's just iterate through the actual list and start shifting items. That's going to be the first logic that we write. I equals index. And now the reason why we're setting the I to equal to index is because that's the current item that we're priming for removal. So we want to set it at that point, and then from there on, we're going to shift everything after that to the left. Here we look at the list size, because remember, we're keeping track of that, and then I plus plus. So here, we're not going to waste time trying to shift anything else. If we reached like an actual empty string, we're going to stop shifting because there's no point to shift anymore, because all the empty strings should be at the end, and this is wasting time. So we're just going to leave early. So we will check if the current iteration that we're at actually is empty. at that certain element, then we just break, because there's, like I said, just no need. So basically what you're doing here is you're just taking the current one that you're at plus 1, and if it's happens to be less than the current size, which, remember, this is virtual, this isn't the actual array size, so if it's less than the current size, then that means that this is an item that we need to actually shift. Now, if that's not the case, then that means that we reached a point where this is an empty item. So that's what we will put there. All right, next, what we want to do is track the list size. So since you can only remove one item at a time, it just makes sense that you would say list size minus minus, which is basically just decrementing by 1. And then lastly, edge case, which basically states that if list size is greater than 0, so meaning that, you know, we still have items in the list, and index happens to be greater than the list size minus 1, then what we want to do is just set the index to the last one. Now what that does is, because let's say if you go to remove an item, like the last item in the list, in the current list, then what would happen is the display would just show like an empty point, because you're still like technically at that item, if that makes sense. So it'll just show like the number and then nothing there. And so what we need to do is we need to go back once, that way it displays the latest, now the new last item in the list, if that makes sense. But that is it. That is the 2 custom functions. Next, we'll be going into the loop, which is going to be a lot longer, and it's going to be the rest of the full logic being all brought together. All right, so let's work on a loop now. So first thing, what we're going to want to do is do what I said before, which we did here, where we actually look at the list size, and if it's 0, then return. We're going to want to do the same thing here. The list size equals 0, just return. Because long story short, we don't want to run any more logic anymore at this point, because there's just nothing to do, because the list is completely empty. So there's no traversing, there's no being able to remove items, so there's no point in running the rest of the logic. Okay, so now at this point we're going to look for button presses, and that could be any button. So it's going to be a long condition, but this condition, like I said, just looks for any one of those buttons that we have up here, the up pin, down pin, and submit pin. And then it also considers the spam control, which we'll bring into it, and then also the button flag. There it is. Pretty long condition, but basically what it states is that if the up button pin is pressed, which low in this case, because by default it's going to be high, so when you click it, it becomes low. So if that button is pressed, or down button is pressed, or submit button is pressed, and the flag is false, basically by wrapping parentheses around it, you're just stating that, like, if it's false, then it's true, right? So because by default it's false, and it should be false if it's not pressed. So if that's true, that it is false, and the current, which actually I don't think hold on, I forgot to put this here, current milliseconds equals, and we're gonna use a function, I think it's like that, mils, yeah. So basically what that does is just gets the current milliseconds from the start of the program. Basically we're gonna take that, and remember our global variable up here, the previous milliseconds, which we define it as 0. So we just do a simple difference to just see if the difference is significant, and in this case the constant that we have up here, 500. So if it is, then we allow it. If it isn't, then that's just controls the spam, so you can't spam the button. So we just have 3 things going on here. We're looking for what button was pressed. Doesn't matter which one, at least one of those buttons was pressed. The flag must be in the up. That means that you can't press 2 buttons at the same time. And then also just spam control, so you can't spam the button. All right, so first things first is we're gonna handle those conditions. So for instance, is button press, what we want to do is we want to set that to true, and then we'll set the previous milliseconds to the current milliseconds. All right, so next what we want to do is we want to handle the actual navigating, right? We want to be able to handle changing the current index, which is our global variable up here, to whatever button you press, if you're going up or down. Now to read from the actual pin, it's digital read, and we're going to do the up pin here. So we're reading from this pin and determining if this was the one that was pressed, right? Because up here it could be any of the buttons, so now we have to actually see, well, what button was pressed, right? So if that button was pressed, then we're going to do some logic here, and then we'll do another else if. I'm just going to kind of copy and paste here. So first things first, when you're pressing the up button, you're basically navigating up the list. So what you want to do with the index is you can do this neat little trick here. And this neat little trick that we're doing, instead of just pretty much subtracting like decrement in the index, we want to handle wrapping, because what if you reach the beginning of the list and then what happens there? You want to be able to, I want to personally be able to wrap back around towards the end of this of the list, instead of just like stopping there. So in this case, we're just going to create this neat little trick here, which will say if index equals 0. So we're at that first one for any operator. Then it's going to be the list size minus 1, which is going to now be the n, and this is the virtual size, remember, not the actual array size. Or it's going to just be index minus 1, which is just basically a decrement. So pretty straightforward. And now here at this point, since you press the up arrow, the actual arrow symbol should be on that first line at 0. So we're just going to say the arrow position is going to be equal to 0. And that's all you need there. So now for the down position, we're basically reversing it, but it's going to look a little different with the actual index and how we do this one. So we are trying to increment here, but we use the modulos operator, so that way we get the remainder, the current virtual list size, and basically that would just wrap it back to the front if you try to go past the actual list size. Pretty straightforward. All right, and then here, when you click the submit button, which is basically our removal button, all you want to do is just call the remove item function. Pretty straightforward. That should handle the logic for us. Here we want to deal with the rendering part. So first things first is to just clear the screen. So we're going to use the instance lcd.clear function. And then what we want to do here is going to be a little tricky, but basically because we've got to consider like if there is more than one item in the list. If not, then the way you got to render it is going to be differently. And then if there is more items in the list, then where's their arrow positions? That way the arrow shows correctly. This is where it's going to matter, you know, what are we passing as arguments. Instead of write it out, I'm just going to copy and paste this from what I did before. So basically, like I said, we're going to look and see, okay, well, are there multiple items left in the list? And if so, we're going to do this logic here. And if there isn't, then it's very simple. All we want to do is just render the item that we're currently on, and the 0, let's just say that, remember, if you come up here to here, the render item, the line 0, so the first row, and then true is because, well, that one has the arrow, right? That's the only one left. So that's a very simple, but the logic inside of here is a little bit more. So yeah, what's going on here is if you have multiple items, then you need to look at the arrow position. So we change the arrow position here, whether it's going to be 0 or 1. So if it happens to be 0, then we know that we're moving up. So we need to render 2 items since we know we have multiple items. So that's why we call the render item twice, no matter what case here. So we're going to render 2 items, but we're going to render it like this. The first item here, since we're going on the up position, this is the current item that we're on. We're going to pass that in. We're going to pass in 0 because we're going to render on that first line, and then true because the arrow is there because we're moving up. And then that second item, just that way we have 2 items shown on the list, it's just going to show what's underneath the item. So that's why we just pass in index +1. The same thing we did up here. We handled just in case if we were at the last item in the list and it needs to wrap around, so that way it will still show, but it'll just wrap around. And then vice versa here. I don't want to over explain that because I feel like it's just vice versa there. And then this is not really necessary because the way everything's set up and the list that I'm using and everything, it wouldn't happen, but I just put that there as to handle just an error, just in case if the arrow position was something other than a 0 or 1, then it'll just let you know that, hey, there's an error. But it's not going to happen because it's only could be one or the other, and there's no other place that I'm updating the arrow position. So last but not least, we have to deal with the reset of the flag. So in this case, when all the buttons are up, which is like the high macro, then we're just going to reset the flag, which the flag member is button pressed. So I'm just going to copy and paste it. It's the last thing we need to do. Copy and paste that there. So basically, like I said, if it is, it has to be true. So if it is true, like it was pressed, and all of these buttons are up, so it won't reset if at least one of those buttons are still down, then we will reset it. Basically, it's pretty straightforward. That is it. So let's test this out. Okay, so I'm recording this later because I realized a few things that I fixed and I just wanted to show you real quick. So we were creating this char array over and over every time we called this render item, and that's not good for performance. So I decided to just remove that from here, create a global buffer, and basically use that and then just clear it. So this is also an extra function which handles clearing that buffer. I also wanted to prefix all the global variables so that way you know it's a global variable. So I ended up doing that throughout the whole entire script. I also noticed for the for loops, I was using integers instead of size t, and it's recommended to use size t. I swapped out the integer for size t. So those are just the quick updates that I wanted to go over so that way you're up to date. It will be a part of the actual code and the repository, so don't worry, it'll be there. You don't have to worry about changing it. All right, I figured I'd just show this. I don't know if you're an absolute beginner or not, but yeah, so once you plug in your board using the USB, you basically need to select it here. If it's not here, you would have to basically go here, select other board and port, and I don't want to over explain that. You just have to look into the actual documentation, but in this case mine's here, Arduino. So click here, now we're connected to it. You can compile if you need to verify that this actually works. So like, let's just verify it real quick. The reason why is because the P right here is lowercase, make uppercase. So that's why it's good to verify first before you try to push it. I mean, either way, it would still compile first and then let you know, but it's good to just kind of check your work. So verify, which see it's compiling. In this case, now it passed. So next, all you want to do is just now upload it, which will flash your program right to your microcontroller. And it's done. Okay, so now we're ready to test it. I unplugged the USB cable because don't really need it right now, because you could just use a 9-volt battery at this point, which is what I have here. Came with the kit. Take this, right? Plug it into our jack here. Voila. Loads up. Grocery list. So there is something going on here, I believe, because remember, it should be showing that first item. Ah, see? That's the reason why. Remember, we commented it out because we didn't make it yet, so we're gonna uncomment, unplug my battery, plug in my USB, and all we're gonna do is just upload it. Okay, so now you can see it shows apples. Perfect. Now all we're gonna do is just test and see if it works. So first things first, remember, this is the up key, this is the down key, this is the key to remove items. So if we go down, that little message goes away and it begins to show 2 items. So in this case, we went from apples to eggs, and the arrow's down here, and we keep going. Now if I was to go up, it'll just go to bread. And see, that worked perfectly, where the arrow just went up to bread, and we go up to eggs. And now if I was to go up from here, it should wrap around. It does that. If I come back, wraps back around, does that, good. If I was to remove coffee, it goes to 14, and it updates correctly. If I was to just remove apples, let's say, updates correctly, went to eggs there and updated correctly. If I just continue to remove everything, keep going, keep going, keep going, and finally the last one, see, it now only shows on that one line on the first line here, and if I try to use these, it won't obviously work. If I had to remove that one, boom, list is empty. And now we're at that point where it gave us a list is empty, and we're not going back in here no more, because now we're at this point here where it's not going to allow us to continue with any of the rest of the logic. So if I try to hit the buttons, whatever, it's not registering nothing. It doesn't matter no more, because we're at this point in the program and we're good. All right, so that about wraps it up. Like I said, this is my first video ever, so hopefully I did well. Hopefully I explained it thoroughly and clear. Let me know in the comment section if you have any questions. I will leave a repository for the code and the wiring diagram in the description below. Also a link to the kit that I bought on Amazon, so that way you can buy the exact kit that I'm using. Besides that, if you got this far, thanks for watching, and until next time.